Hello everyone, and welcome to today's chem lesson. Today we are going to talk a little bit about the difference between an empirical formula and a molecular formula. We're also going to look at some of the types of problems, right? Some of the types of questions that you will be asked in relation to these concepts. Now, an empirical formula and a molecular formula can both be used to represent the same compound. The big difference is that an empirical formula looks at the simplest ratio that molecule can have, while a molecular formula is based on the molecule exactly, what is in that molecule. Sometimes they are the same. Sometimes an empirical formula, the simplest ratio, is the same as the compound itself. For example, something like water. A molecule of water contains 2 hydrogens and 1 oxygen, making this the molecular formula. This is exactly what one molecule contains. This is also the simplest ratio, though. You can't get a ratio simpler than a 2-to-1 ratio. And so this doubles as the empirical formula for water. Now when we go and we look at other things, right, I've got a whole chart, and when we go and look at these things, we see sometimes they are the same, right? Sometimes molecular and empirical formulas are the same. Sometimes they are different. The molecular formula looks at exactly what's in the compound. The empirical formula is the ratio, the simplest ratio. Sometimes 2 different things can have the same molecular or empirical formula, and that is totally fine. Or you can have 2 different things with the same ratio. Empirical formula is all about the simplest ratio. Molecular is all about exactly what is in the atom or molecule. And now sometimes we're going to get practice problems and questions that ask you, what is the empirical formula for C6H6? Right? How can I simplify that down to the simplest form it can get? And for those, we're just going to look at the subscripts and see how much we can reduce them. Right? 6 and 6 can be reduced down to 1 and 1. 2 and 6 can be reduced down to 1 and 3. But other times we're going to be asked to go backwards, to go from empirical formula to molecular formula. And that's where things get a little bit trickier, because as we can see here, one empirical formula can have multiple different molecular formulas. And so that's where some of that mole calculation and gram formula mass knowledge comes into play. Right? Like I said, sometimes it's really easy. Sometimes it's just if you have C8H12, what is the empirical formula? And you look at these things and you reduce them by 4 to get your empirical formula. But other times we get problems like these 2 that are down here. In these cases, they're giving us an empirical formula. And they're asking us to find the molecular formula. And in both of these problems, we're actually going to take the same approach. We're going to look at the relationship between the empirical formula and the molecular formula. And we're going to compare that to the mass of each thing. Since we just reduced to go from molecular to empirical, we should just multiply by some number to go from empirical back to molecular. And all we did to go from molecular to empirical was divide by some number. The problem is that we don't know what that number was. We don't know what we divided by to go from mystery thing to NH2. And that's where this molar mass bit comes in. The relationship, right, whenever we're going to multiply our empirical formula by to get our molecular formula by, is going to be the same ratio as the comparison between the two masses. So if I look and I want to plug things into this schema, here they've given me NH2. Right, let's just do this here. They gave me empirical formula of NH2. So we're going to stick that right where we have our empirical formula. They gave me the molar mass of the compound is 32. I need to find the molecular formula. And I also need to find whatever I need to multiply by. I need to find my multiplication factor. But that's all the information they gave me. I'm still missing a number here. I'm still missing the mass of my empirical formula. And that's something I can find by using the knowledge that we gained last time, right? Knowing that to find what 1 mole of NH2 weighs, it would be the mass of N plus the mass of H plus the mass of H again. 14 plus 1 plus another 1, because there's 2 H's, gives me 16 grams. Now I've got 3 of my 4 pieces. Now I can look at the relationship here. What do I need to multiply 16 by to get 32? That is a doubling. I need to multiply it by 2. If I multiplied the mass by 2, I must multiply the formula by 2. Which means my final answer here is going to be double whatever this is. N2H4. And that's my final answer, is this N2H4. This is the molecular formula for this thing. And we're going to see this pattern, right, this information pattern, where this is left out and this is left out, pretty much in every question we look at. So let's take a look at this practice problem. We're going to set it up in purple again. Right, again, they're saying calculate the molecular formula, so we need to find the molecular formula of a compound whose molar mass is 90. Okay, so they gave us the mass of the compound. And the empirical formula is C4H. Sorry, CH4N. I know how to read. I promise. Now I'm going to add this piece of information up top for you. And I want you to take some time and see if you can solve this out. when we take a look at this, the only problem left on the page, our first step is going to be to find our missing piece of information. CH4N has a mass, and we're going to find that mass by taking 12 plus 4 plus 14 to give us 30 grams. Then, now that we've got all the pieces of information except for the one we're looking for, we're going to find our ratio. To go from 30 to 90, I multiply by 3. If I multiplied my masses by 3, I'm going to multiply my formula by 3. And that is going to give me a final number, or a final formula of C3H12N3. Let's put that C3H12N3. Right, multiplying this by 3. Alright, here we go. I've got more practice problems for us. I want you to take about a minute of on-screen time, but as much time as you need with a pause of the video to solve these out, and then we will look at them together. Our answers to these questions are right here. The first one just asks you to simplify. Right? What is the empirical formula of C4H12? Which means we want to reduce 4 and 12. The simplest those can be is dividing them both by 4 to get 1 and 3. The second and third questions are using that same pattern that we saw before, looking at the empirical formula's relationship to the molecular formula and comparing the mass of each. For the first, let's move back to, right. They give us CH2O to find mystery thing with a mass of 150. We can find 12 plus 2 plus 16 equals 30. And that relationship is a multiply by 5. So our final answer becomes C5H10O5. For the third one down on the bottom, they give us molar mass of 174 to find our mystery thing, which weighs N2H, 14 plus 14 plus 1 is 29 grams. We find the relationship between these two numbers is multiplying by 6 for our final answer of N12H6. To close this out for today, I have one multiple choice question for us. We're going to take a look at that now. Which one of these four things is an empirical formula? Looking at this, we know an empirical formula is the simplest ratio between the atoms. C2H2 can be reduced down to C1H1. Same thing for H2O2, H1O1. C6H12O6, CH2O. The only one of these four things that starts out in its simplest ratio is choice 2. Right? It is the only one of the bunch that is an empirical formula. It is also a molecular formula. Right? All four of these things are molecular formulas. They look at molecules exactly as they are. And again, it's totally fine for it to be both an empirical formula and a molecular formula. And with that, I'm going to transfer us over to our Zoom for questions, comments, concerns, and attendance. And I will see you there.